Today we are going to talk about how OTA differential upgrade is implemented. The following are some of my ideas for implementing differential upgrade, as well as guidance on the upgrade process. In order to facilitate everyone's understanding of this differential upgrade, we will now talk about how it's implemented. Firstly, we use a differential algorithm between the old package and the new upgrade package to obtain the differential package, which contains the validation data. This is our differential package. In the flash partition, there are boot partition, runtime area, status data area, patch package area, and merge package area. And our upgrade process is to first download the upgraded patch package, which is the upgraded differential package, to the patch package area. After restarting, return to the boot partition, and then the boot will combine the data from the runtime area with the data from the patch package and put them into the bundled area. Then, the boot partition will move the data from the bundled area to the runtime area, taking into account both verification and status adjustment during the transfer process. After the transfer is completed, it jumps from the boot partition to the runtime area for operation. The above are all steps for upgrading. In theory, the data in the running area and the patch area should continue to be generated downwards, and it should not have any impacts. So why can't the package area and the operation area be placed in the same area? This is determined by the BSDIF algorithm. You can see this image of the algorithm, where the top line represents the patch package. The red part below represents the old package, and the bottom line represents the new package. The patch package consists of 3 pieces of data and 2 corresponding data segments. Firstly, the difference data marks the length of the first data segment, which is the length of the old file from 0 to the end. They are added together to obtain the length of the new file. The second one is an additional part, which will be directly transferred from the patch package to the new package. This process means that if we add some data, which is something that does not belong to the old package, we'll put it directly in the form of a patch in the new package. This is the process of obtaining a new package, which is woven from an old package and a patch package. The third data is to adjust the position of the old package, which means that after I add it, it reached the end here. When I add the actual part, the position at this time may be moving forward or backward, determined by the third position parameter. Therefore, when we synthesize the new package here, when the running area goes 10%, the verification area and the patch package go 10%, and then the reassembly area produce 10% of the new package. Theoretically, they do not interfere with each other at this time. However, if the third data is rolled back, there will be problems when it reaches the new package, and the new package will not contain the old data anymore. This is the reason why the package area and the operation area are separated. So the algorithm idea of BSDIF is to repeatedly add 3 data points and 2 data segments, and constantly create new packages to obtain new firmware. Now let's look at how this code is implemented. However, I won't explain the code itself or what the algorithm needs to achieve. Instead, I will only demonstrate how this feature is used. Firstly, it consists of two parts. The first part is the boot, and the second part is the app part. This app part is upgraded through the web, and then the partition range and the partition situation are shown in our diagram. Okay, let's take a look at how it works. Let's enter the boot partition. Okay, the boot partition code has been successfully compiled. At this point, we'll compile the app section again. I've already synchronized the code to my repository. I will include the repository link at the end of the video or in the comment section. Okay, both of these have been compiled. Let's open the burning tool, connect the development board, connecting the burning serial port and the serial port. Open the boot code to be burned. The boot is burned to its base address, the one starting with 800. Then the app part is burned to the position starting with 801. These two places need to be burned twice. Let's clear them first. Click on the position of the image with the mouse, and it will be burned to that position. Good. We've burned the boot and app parts in. Let's open the serial port and take a look. Start the device. Here, it jumps from the boot to the app part and prints out the version, and its already obtained IP. We can access this IP via the web. It's actually an upgrade page. This upgrade page has also obtained the corresponding information. Since we want to upgrade, we definitely need to modify the package of the app part. Let's go to the app part and change the version number. To make a distinction, let's change the version. After changing it, we need to save the old package. In the OTA BSDIF app web here, there is a tool. Let's move the old package into it first and rename the old package. Changing the name is for easy input when making differential packages, and it doesn't make much sense. It can be left unchanged. Okay, let's compile the new package now. Once it's compiled, we move it in as well. To make a difference, we'll give it a name called new.bin. Okay, let's go to a directory where we have tools for creating differential packages, new packages, and old packages. Let's take a look at how to use this tool. Currently, this tool does not have permission, so we will give it permission. chmod. Give 777 permission. It should have execution permission. We are now making this differential package. We can run bsdiff to see how it works. It prompts some information, and the usage is here. Run the bsdiff tool and give the names of the old package, new package, and differential package. Now let's run it. First, we put the old package, which is this one, and the new package is this one. The name of the differential package is patch.bin. We've already created a differential package here, which is only 279 bytes long. We will download it and see how big the difference is. Let's compare the original full upgrade of these two packages, which require upgrading 129 KB. And now the patch package, how much does it only need to upgrade? Only 310 bytes. In the case of relatively few changes, this differential package is very small. But if there are many changes, this differential package will also become larger. However, compared to over 100 KB, this is only over 300 bytes, which is very small. For some scenarios, such as LoRa, its transmission rate is not high and the data volume is very small. In places where traffic is expensive, such as satellite communication, its significance can be imagined. Okay, let's refresh it. Each time we refresh, we can get the print information here. Here, we select the differential package we want to upgrade. Find our differential package in the tool and click Upgrade. It will be downloaded and completed. Okay, it has already printed out this version here, 2.0.0, which is the same as what we changed. Let's take a look at its printing information. Firstly, the first three are refreshing the web page. Here, we download it and complete the reception. Then, we restart the device. After restarting the device, it returns to its boot partition. Firstly, download the patch package into Flash, and then restart it into boot. Continue with the package merging process. The information printed here is the action of merging and the running area, and patch it into a new package. At this point, the merging is complete. After the merge is completed, the next step is to move the data in the merge area to the runtime area, which requires a total of 129 KB of new package data to be moved. After the transfer is completed, it will jump to the boot area to run the new package, and then print out the version. And the new package is similar to the original. The only change is here. That's all for today's sharing. Thank you, everyone.